All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be doing another study stream. We are doing more PyTorch studies. I've been busy doing research on various functions. So far, I've been focusing on the linear function and the ReLU function. I haven't really gotten into the ReLU side yet because I'm still focusing a lot on the linear function. Yesterday's stream as well, we were supposed to do a bunch of like PyTorch stuff, but I ended up getting distracted with a bunch of other things, and then we also had some internet issues, so there was some scuff on stream. But hopefully today we should be a little more productive. I mean, we were kind of productive yesterday as well, but like I was getting different kinds of research done. I got to learn some stuff. So okay, this is something interesting because I don't often find myself implementing classes that inherit from other classes. Like inheritance is not it's not really something that I use a whole lot in terms of like when I'm implementing my own classes, but I have used inheritance in the sense, for example, in Unity, when you create a script, by default, the script inherits from mono behavior. So like in that sense, I've been using inheritance. And even in Python, I'm sure there have been certain libraries that I've used where I had to implement a class that inherited from something. PyTorch is a good example as well. If you're building a neural network, any kind of neural network, it's going to inherit from nn.module. Module is the base class for implementing neural networks. It's a base class for all neural networks. So that kind of raised a question in my mind about okay, to be honest, I wasn't really even sure what exactly I was trying to find out. But eventually I did find out. I was trying to understand that, okay, we are not instantiating the inherited class. Like there's no instance of the inherited class, but the class that's deriving from the inherited class, we create an instance of that. So is there like an internal instance of the inherited class that's created? Apparently that's not the case. It's not usually an inherited it's not usually an instance of the inherited class. It's just when the memory allocation is done, there's extra memory allocated for various properties and fields of the inherited class as well. And that's kind of where my doubt was coming in. Well, prior to learning that is where I was kind of confused about how exactly are we setting the values for various variables, various fields and properties in the inherited class. Like, is there a separate instance of it, or are we setting like global values that would be shared across multiple other classes that inherit from this class? That's kind of where like my confusion was coming in from not understanding how exactly the inherited classes fields and properties were were being instanced. I guess that's the best word to use. Yeah, I wasn't able to understand, but then I did more research on exactly how inheritance and the memory allocation around inheritance works, or at least I got like a very basic idea. I even asked Gemini. I even looked uh, at some answers on Stack Overflow, and uh, it satisfied my curiosity. Let's just say that. And now I'm ready to get back into. Actually, I've already gotten back into it. I've been doing okay, it in this case being PyTorch and neural networks. So yeah, I've kind of already gotten back into it, and I've been looking into the linear function. So I'd mentioned this before. I want to explore each of these functions, be it be it one of the neural network layer functions, or be it an activation function, or anything anything that's involved in the training process. Like, for example, give me a second. Sorry, had one of those sneezes that didn't want to come out. Yeah, I guess the best way is to show. So I want to explore everything in here. Of course, I'm not going to go like, uh, topic by topic and look at every single function. But as we start learning more and more, like I feel like we should move forward with this section. It's just that I kind of got hung up on these two functions, which that's not really a bad thing, because that's kind of how I want to proceed with my learning. Because like the way that it's being done here is, okay, you create this class that inherits from module, and then in the class you set up these fields, or these attributes, I guess we should say. I'm not sure. And then in there you set up like the sequential stack, and the sequential stack is going to contain all the various functions that you want to chain together to build the neural network. Now that's your basic feed forward neural network. And in this alone, we have like a couple of things to explore. So it's not enough for me to know that, okay, I need to create this class and then create an init method with all of this stuff, and then create a forward method that gets executed when you call this class. Wait, you call the class, right? Yeah, you call the class. So the class does have a call method. I'm guessing, like, because we haven't implemented the call method here, I'm guessing the call method is implemented in module. And apparently, a bunch of the others also derive from module. A bunch of them inherit from module. I think linear also inherits from module. I don't know about relu, because relu is an activation function. It's not a it's not one of the layer functions. It's not something that. Okay, I was about to say it's so. I was about to say that relu doesn't transform data, but that's not entirely true. It does transform the data to make it nonlinear. So that's probably not the best choice of words. Okay, I'm forgetting where I was going with this, but yeah, I wanna explore. I wanna explore. Oh yeah, I was saying that linear derives from module. I don't know if it really does, but like the research that I've done has been saying that, yeah, linear also derives from module. I don't know if relu derives from it or not. And the interesting thing is, with a bunch of the functions that you have, I haven't explored this fully, but with a bunch of the functions, you're able to like create your with a bunch of the functions, you're able to create like a group of functions within them as well, like a group of layers and activation functions within them as well, similar to this sequential thing. We'll be doing a similar thing once we get into recurrent neural networks and convolutional neural networks, because in both of those types of neural networks, you're doing slightly more complex stuff. Their working is a little more complicated than just basic matrix multiplication. With linear, it's pretty much just basic matrix multiplication. Though there was something that I found out. So okay, the this is great. Um, where is it? I always get lost in this. Linear layers, linear. No, convolutional layers, linear. Okay. So this is great. I like that with many of the functions, they actually give you the math behind it as well. So this, for example, it states that y, which is the result, is equal to x, which is the input, multiplied by the weight, or the weight matrix, plus the bias. The interesting thing here is that the weight matrix is transposed. I've been looking into why exactly the weight matrix needs to be transposed. I'm still trying to understand the idea behind that, and more importantly, I'm trying to understand how it doesn't adversely affect the calculations. I feel like I need to do these calculations on paper, quote unquote, on paper. Like usually when I say on paper, it's like opening up a new markdown sheet kind of thing. But like I'm gonna need to visualize stuff. You know what we could do? Okay, give me a second. So there's a neural network visualizer tool called NNSVG. I need to remember this name because unfortunately, when I look up neural network visualizer, it shows a lot of the other tools. It doesn't show this tool. Though, speaking of the other tools, there's another one. There's actually a list of them. Hold on, I'm gonna show you. So I'm gonna open up NNSVG first. NNSVG. Okay, and then I'm gonna look up neural network visualizer. Oh, there's also one from TensorFlow, so I'm gonna look into that as well. And then this repo that has a list of visualization tools. So I'm gonna first show you that repo. Let's transition back, dude. Okay, I feel like at this point, now we have gotten to a point in the VTuber apps development process where or I feel like the app has made enough progress that we are ready to have a custom BRB screen within the app itself, and I feel like I can work on something like that. The only thing I would need to do is place the spout capture because the app itself is using spout to to uh, to share the texture. So whatever is being rendered in Unity, it gets captured into like a spout texture, and then the spout server shares that or makes it available for any other client that wants to read that texture. And in this case, OBS reads that texture. Why was I saying this? Yeah. So basically, I have a spout capture for capturing the window, for capturing the VTuber app window. By the way, shout out to like all the people that have helped make Spout what it is today. Like it's crazy. It is awesome. But yeah, okay. Enough of that. The Spout capture, I need to place that at the very top of the list so it renders above literally everything else. To be fair, it's kind of already doing that to a certain extent. What I've done is I've placed, I think, chat. No, I think it's rendering above chat as well. Hold on, let me just look at the list real quick. So I have two images in on the right side of the screen, in the lower right side, which is the VS Code logo and the Python logo. Those two images are rendering above everything else. Then I have like a text source, which I mainly only use when I'm doing mute study streams. So that's disabled right now. Then I have some kind of browser source. I don't remember what this was for. I don't remember if this was for notifications or for something else. I'm going to have to look at that. Then I have the spout capture. And then the chat source is below the spout capture. So the VTuber app renders above the spout capture as well. So the only thing I would need to do really is place these two images and the text as well below. No, the text should be above because the text is usually, yeah, okay, that might complicate things a little bit. I would need to be careful with how I'm going about doing that. Or okay, so another thing I could do is I could just set up um, another thing I could do is I could just set up, what was I going to say? Words. Holy shit. I was going to say something. Another thing I could do. Oh, yeah. I was going to say that I could just set up a separate BRB screen the way I have right now. And then like switch to that BRB screen. The only thing that's going to be captured in that BRB screen is the VTuber app. And so then I can like transition and have the entire BRB screen be there. The only like slight inconvenience there, I guess, would be having to switch scenes, which is, I mean, it's not really an inconvenience. It's going to be like an extra button press. I'm going to have to do a bunch of work on the Unity side to set up the BRB screen and change like the camera angles and stuff like that. Oh, another thing I want to do with the VTuber app. So there's three things on my mind right now for the VTuber app, at least. One is the BRB screen, right? Another is setting up some kind of mini game. Not necessarily a game that you can win, but just some kind of like fun activity for the chat. Something that people can play by either entering commands in the chat or using channel points. So that's two. And then three is setting up a scene for just chatting. Setting up some kind of scene that I can start the stream with, or basically some kind of scene where I'm just chatting. So I can be in that scene when I'm talking, and I can do this thing where I capture some of the windows. And actually, no, that would become complicated. Capturing the windows. I was gonna say that I can like whatever is being rendered on the screen right now, minus the VTuber model. I could like somehow green screen that into the 3D scene. But no, I'm gonna have to find a different way to go about doing that. Yeah, I'm gonna have to find a different way to go about doing that. It's fine. I mean, I can still set up a scene. Having this exact scene being shown, because like what I wanted to do is I wanted to have like a monitor or multiple monitors set up. I still have to decide like what I want the entire setup to look like. I have to see what what's the background supposed to look like, what am I supposed to be seeing in the scene, because like what I'm supposed to be seeing and what you guys are going to be seeing, it's slightly different. um it's a lot of it is going to be like just for like show, just as a background kind of thing. So I have to make the stuff accordingly, but I want to make it in such a way that I'm able to be within that space. I even like fit into that space. Oh, dude, yeah, I also need to continue learning about VFX graph, dude. Like, I've just pushed that to the side completely. I need to get back into doing VFX graph stuff because I wanted to do like a ton of projects using I still want to do a ton of projects using VFX graph. I just need to pick it back up again and relearn whatever basics I had learned, and then go from there. Keep expanding, keep building my knowledge by making various types of VFX stuff. Okay. Getting back to this before we get too sidetracked. So this is a list of tools. Shout out to this person, Ashish Patel, 26. This person made this list. Actually, I don't know if this person alone made this list or a bunch of people contributed to it. But this is a list. So there's a couple of tools here for neural network visualization, and they all have their pros and cons. They all have their uses. Uh, NNSVG is part of that list as well. And another one that's a part. Okay, I haven't played around with this yet with plot neural net, but one that I have. Actually, I've tested out a bunch of these. At least the ones that I could without having to, download the library and build the architecture using code. I've tested those out. Um, this one, Netron. This is interesting because this is like a full-fledged. Okay, I don't even know what full-fledged neural network visualizer would mean in this context. I don't know why I said full-fledged, but this is like you can visualize. I think you can visualize a bunch of different formats in this, but Onyx is one that's definitely supported. So I can open it up real quick just to show you guys. There's an example here of, I don't know what kind of neural network. I think it's a convolutional neural network. But there's an example here, and I want to do this. I want to export a very simple feed-forward neural network in the Onyx format, and then what was I saying? Yeah, I wanna export a feed-forward neural network in the Onyx format, and then upload it to this. So I clicked on that link, which kind of brings us here, and it opens up that thing. Wait, this is interesting. Are we just able to pass? Are we just able to pass this? Are we just able to pass like GitHub URLs? Holy shit, dude. Okay, that's convenient. That is actually convenient. I didn't realize that earlier that that's all this was doing. You can upload a thing to GitHub. You can upload a model to GitHub and then have it pull the model from there. Actually, I don't think you're going to be limited to GitHub alone. Basically anything that can, because it says raw. So basically anything that's serving up a file, as long as it's serving up the file, this thing should be able to read it. Hold on. Before we continue, give me a second. Okay. All right. So, this is the model that's been loaded. I didn't notice this before. I just alt left clicked and the thing popped up. That's interesting. Yeah, I didn't know it had these tools as well. But yeah, this is the um what am I trying to say? Yeah, this is the way that this app visualizes this neural network, and you have like various nodes for various things, and you can click on each of them to get different types of information about, be it a layer, be it an activation function, be it a pooling function, or I think it's a pooling layer. I don't know. We're gonna get into that later. Or even the data. I think, does the data give you something? Yeah, I think the data gives you something as well. So this is how this thing visualizes a neural network, right? This is one way of visualizing it. I want to use this. I also want to use this, which gives us the classic, like fully connected. Um, I forgot if the NN stands for neural network or something else. Fully, I don't remember. Wait, hold on. Uh, let me just ask Gemini, what does FCNN stand for in neural network architecture? Fully connected neural network. Okay, all right, yeah. So there's this style, which is fully connected nodes, where each node in the previous layer sends input to each node in the next layer. And so each node in the next layer is expected to receive input from each node in the previous layer. And then the process just repeats like that until it gets to this. So this is one architecture. There are three architectures supported by NNSVG. One is fully connected. The other is Linnet, which is this. And the other is AlexNet, which is this. And each of these architectures has its own like pros and cons, because they operate in like slightly different ways. I need to study each of these architectures, maybe not too deep, but like I still need to study each of these architectures because so I feel like Linnet and AlexNet, I think both of these would be convolutional neural network architectures. I'm not sure how recurrent neural network architectures are being visualized. I'm not sure if this tool is able to do that. I have no idea. I'm gonna have to check. But for the time being, I'm learning the most basic. Uh, what did I just do? Yeah. For the time being, I'm learning the most basic neural network type, which is feed forward. So I'm gonna hold on. Why am I not able to scroll this? All right, whatever. So for what I'm doing right now, I just need this. Right? So we have the input layer, which contains one input. What is this supposed to be? I'm not sure what this is supposed to be. Is that a weight? Okay. And then we have this, which is our, well, this is not supposed to be the output layer, but like, actually, yeah, this is. If we think about it, this kind of is. Because this is outputting 4 weights. For the time being, this is what we have set up. I could then like send it into, oh, this is the width. Okay. Okay. This is like the spacing between the nodes. All right. Uh, I could set up an extra layer here, which would then be considered the output layer. But considering our current setup, like if we are looking at this, hold on. This is all code that I was looking at yesterday because a lot of the stuff that I'm doing here, it's not necessarily how you go about doing it, but like I'm doing it for debugging purposes to be able to like understand a lot of what's going on. So basic the basic working elements in this whole operation are your input and your weight matrix and your bias matrix or your bias vector. And then of course you have the output as well. So I needed to read all of those values. So that's why I was writing a lot of this code because I wanted to do the math behind each of these myself. And the math for this is simple because like I believe I'm setting the bias, not the weight. I can set the weight as well manually, but like it has been mentioned that you're not really supposed to be setting it. The way that neural networks work. I think there's like a fixed workflow that they use for the training, and so unless you have a very good reason to be doing something custom, you usually just go with their set workflow where you use something called optimizers to generate the weights or to set the weights based on your training process, because the weights are going to be constantly changing throughout your training process. That's kind of how you determine what the best weights are. You set the weight to something, run your simulation, run your inference, and then check the output and see how far away it is from the expected output, and that is your loss function. That is your error, basically. And then based on that error, you change the weights again, and then run the inference again. Oh shit! I missed the ad timer. There's going to be an ad starting in like, I don't know, 30 minutes or something. No, 30 minutes. No, 30, maybe 15 seconds, 10, 15 seconds. So yeah, you change the weights again, and then you run the neural network again, and then you check the output and compare it against the expected output again, and you basically repeat this process, and you keep repeating this process until you've minimized the error to a certain degree. That's how your training happens, and throughout this time your weights are constantly updating until you reach the perfect set of weights that give you uh, a satisfactory output. Let's say, I was about to say the perfect output, or okay, there's the ad playing right now. So I'll see you guys in 30 seconds. Okay, welcome back. Dude, I just got an idea. If the Twitch API allows me to detect when an ad is playing right now, or well, when an ad starts playing, if the Twitch API allows me to detect that, I could set up a system in the Twitch middleware app to check whenever an ad is playing. And if an ad is playing, then I will send a message into the chat saying that, an ad is playing right now. And then in the VTuber app, I can set up a script to check for ad breaks. So anytime there's an ad break, then some text will pop up saying there's an ad playing right now. Though I wonder if I should start using the OBS library as well. Not really the OBS library, but okay, so there's two ways that I can go about this. One, I could set up scripts within OBS itself, because OBS does allow you to do Python scripting. So you can like create custom plugins and stuff for yourself. That's one way that I can go about it. Another way is I could use their WebSocket server, because they do have a WebSocket server set up that responds to commands. You would have to format those commands in a specific way, but there are libraries that help you do that, that help you construct the message. And actually, there's, what, we could look that up right now. Um, what should I look up? Either OBS C Sharp or OBS Python. It'll be one of the two. Okay, so let's do OBS C Sharp first. C Sharp API. Hold on. obswebsocket.net. Somebody has made that. Great. Awesome. Shout out to that person. OBS WebSocket Python. I should probably look at that first. So we have WebSocket Py. Okay. Python script to connect. So okay, the issue is not going to be connecting to the WebSocket server. The issue is that even after you connect, it's not just like a bare bones WebSocket server. Hold on, let me transition back. It's not like a bare bones WebSocket server. It's, oh, actually, you know what? If I do manage to set this up, then the transition is definitely something that I'm going to be looking into as well, where I can like just send in a command to transition to a different. Though I don't know how good of an idea that is. Yeah, to a certain extent, that has to be done manually because I need to make sure that the scene that we are going to be transitioning to, I've set the right scene. It's not the wrong scene. But anyways, okay, we are looking into this. So we have this OBS WebSocket.net, official .NET library written to communicate with an OBS WebSocket server. This library is available on the NuGet gallery. See the test client project for a working example. Okay, so this is one thing that I could use. Great. Another thing I could use is Python, which would require something like this: Python library to communicate with an OBS WebSocket server. Because the WebSocket server has its own, the OBS WebSocket server has its own protocol, which is described. Is this the GitHub link? I think this is the official one. I'm not sure. Let me just check. Okay, so what is? Yeah, okay. So this is WebSocket. Um, the API, or well, yeah, kind of the API, the protocol. The protocol is described somewhere here. My fucking mouse wheel, dude. Can you stop? Fuck's sake. Okay, so they have the client libraries written listed here. Some of them are not in use anymore or not in development anymore. So I need to kind of be mindful of that. Then there's this one which uses async IO. A simple OBS WebSocket library for a simple OBS WebSocket library in Python for people who just want JSON output. Who just want JSON output. Wait, so can I not send in commands? Oh, good. Okay, here's the protocol. I'm glad this person linked it. Like it links back to the OBS WebSocket repo. I also don't know if the protocol has changed since then. But yeah, this is their entire protocol. There's a specific way to go about doing things. Words. There's a specific way to go about doing things. There's a protocol that you have to follow. You would have to format your messages in a specific way and do certain things in order to set this whole thing up. So just connecting to the WebSocket server is not, it's not enough. Because of that, I need to make sure that I'm using a library that does this for you. So I have two choices here. One, I could I could do it via C Sharp, Or two, I could do it via Python, but the choice of which one to go for would depend on whether I want to set up the functionality in my virtual Stream Deck program, or if I want to set up the functionality in the vtuber app itself. I don't think I need to set it up in the vtuber app. Yeah, I don't think it's necessary to set up the functionality in the vtuber app. Oh, actually no. If I set it up in the if I set it up in, how would I go about doing this? I was about to say that if I set it up in the virtual Stream Deck, I would then have to send those commands to a different. Well, I would have to set up a WebSocket client in the VTuber app itself, which would then receive the data from the various buttons. No, I feel like that would change the structure of. Um, yeah, no, I feel like that would change the structure of the virtual Stream Deck app. I need to think of where exactly I want to place this functionality, because there's multiple places that I can put it. To be honest, I could also put it into the middleware app, but that doesn't really make sense. Putting it in the middleware app is it doesn't make sense. I could put it into the VTuber app, but then I would be receiving the commands from the virtual Stream Deck app, and then I would have to set up a WebSocket client in Unity, or well, the library that I'm using is going to set up the client, and that client is going to be connecting to OBS. Actually, that's not bad. That's not a bad idea. I could do that. I could do that. I could do that. Definitely. I have to see. Okay, the .NET thing is not even mentioned here, which is fine. I'm wondering if I should set up a different. I'm wondering if I should set up a separate app for OBS, like set up a separate script that handles the OBS related stuff, and then that app is gonna receive. How's that app gonna receive data from the VTuber app, or where is it gonna receive the data from? That's the important thing. Where exactly is it receiving the data from? Because it would have to receive data from somewhere. Or another thing I could do is I could just set up a separate. Yeah, okay. I could build like a dedicated app for for OBS specifically. But no, I wanna try and find a way to put it into, like, fit it into the virtual Stream Deck app. The thing is, initially I hadn't thought about this. Initially I hadn't thought about the virtual Stream Deck app sending data to like different apps. It was mainly supposed to be sending data to the VTuber app alone. But okay, keeping OBS aside, because like for the time being, it's not. Yeah, I feel like. Wait, give me a second. Okay, so what was I saying? Yeah, I feel like this is not something I should be spending time worrying about right now because I'm not really going to be using too many features from it. Because the whole idea for me was to try and bring as much functionality into the VTuber app alone so that I don't have to set things up in OBS. At the very, at the most, I was about to say at the very least, at most, I would have to set up a separate scene, for example, for BRB, and then transition to that scene, and then everything else gets handled in the VTuber app. So I don't think I need to set up. I don't think I need to worry about uh, any OBS library. For now, what I could do is I could go with what initially brought up this idea, what initially brought up this thought. I can fix that, or I can implement that thing, which was basically figuring out when an ad is playing. I need to look into the Twitch API to see if there is anything that actually does that. Let me look that up right now. If there's like an endpoint, or if there's some pub sub topic that I could listen to for that. Twitch API, check if ad is playing. Detecting when an ad is played, but this post is from 10 years ago, so it's definitely not going to be up-to-date information. Okay, so let's look into the endpoints. Okay, ads, start commercial, get ad schedule, and that's it. Is there anything else ad related? Okay, now it's just showing me a bunch of words that contain ad. That's not helping. Okay, this is helping. Ad, okay. Then there's bad. Okay, let's add a space here as well. Get ad schedule. Okay, this narrowed it down to 19. Oh, you know what? I could do that. I could do that here. I could bring it up here. Twitch API ad. This brings up the reference. And we can transition. Dude, I need to see if PubSub supports something like this as well. If PubSub has something that we can like listen to. Yeah, API request, add endpoint / subscription. Somebody has mentioned this. All requests and suggestions for first-party products should be under user. Okay, all right, fine, great. That's where staff will see them. This is a third-party community forum. I didn't know that. Okay. So discuss.dev.twitch.com is third-party. Okay. So this was not helpful. Okay, for the time being, I found this one thing, right? So we have ads here. I'm just trying to find a way that shows this. Okay, so we have like 19 over here. Okay, add. Okay, okay, okay. Snooze next ad. Okay. So I'm guessing these are the only three uh, endpoint related things. Okay, so we can get the ad schedule. What does the ad schedule return? I think I'm gonna need to update my the scopes and generate a new access token, which is fine. I can set that up. In the response body, it gives a list that contains information related to the channel's ad schedule. It just says that's an object, but like what data is it? Okay. Snooze count, snooze refresh at, next ad at. This is the timestamp of the broadcaster's next scheduled ad in so and so format. Empty if the channel has no ads scheduled or is not live. Okay. All right. Yeah. I could use this. I could use this. I would have to set up a simple system that checks every, I don't know, 15 seconds or something, or even checks every 30 seconds if an ad is like scheduled, and then based on how much time is remaining for the ad when the next ad is supposed to play. Though, okay, this doesn't say that there is an ad playing right now. I need to keep that in mind. It doesn't say that there's an ad playing right now. And usually when the ad timer runs out, there's a little delay before the ad starts. The delay can be anywhere between honestly 5 seconds to even 30 seconds. Like I've had that happen before. Fortunately, my ad breaks are only 30 seconds long, so it's not that big a deal. Okay, you know what? Enough of this. We were supposed to be doing neural network stuff, but then we just ended up getting distracted. Um, I guess that's just how this goes. So this is another neural network visualization thing, though this is not just limited to visualization. There's like you can do a bunch of other stuff in here as well. Like I think you can actually start a training process here. I haven't played around with this too much. I need to mess around with this because like initially when I looked into this, I didn't fully understand what I was reading or what I was looking at. So I need to look into this and like play around with it. Now that I'm kind of getting familiarized with neural networks, a lot of the stuff going on here should make more sense to me. But for the time being, this is satisfactory because this, at the very least, it helps me visualize what I'm doing. Now, okay, let's remove. How do I make that layer disappear? Oh, that's how. Okay, we just leave it blank. Okay, so far in my code, it seems like this is what I'm doing, right? Because I'm just passing. I think I've commented out uh, the nonlinear activation function code, or basically the activation functions. I've commented out that code. I'm just running the input through this layer, and it's doing is doing a calculation. Now, I need to do this calculation on paper in order to be able to properly visualize it, because there's a bunch of different things going on and I need to like slowly understand each of those different parts. Right now, the part that I'm trying to imagine is the transpose of the weight matrix. So, oh, you know what? Uh, I don't think the transpose of the weight matrix is going to matter because, and see, this is where visualization can help. I don't think the transpose of the weight matrix is going to matter because, um, so each of these neurons has a weight matrix for the input. Actually, no. Hold up. Each of these neurons has a weight matrix for the input? No, it has a weight matrix. Okay, so each of these neurons, like keeping aside the input layer, this layer, the linear layer, each neuron has a certain number of in features and a certain number of out features. Or the layer itself, it has a certain number of in features and a certain number of out features. How many out features it has is how many neurons we're going to be seeing here. Okay, this is not fact. Okay, I'm just like I'm just like I'm just like vocalizing my thoughts to make sense out of it. Like this is what I think is the case. So when we define the linear layer, we're able to define how many input features it'll have and how many output features it'll have. So if we count this as a linear layer, its input features. Oh, actually, then this should count as a linear layer, shouldn't it? Yeah, this should count as a linear layer. Oh, I didn't know we were able to do that. Hold on, dude. I didn't know we were able to do that. How do I zoom out, though? Okay, how do I zoom out of this? My mouse wheel doesn't... Wait, does this do it? No, this doesn't do it. Can I do this? Oh, that does it. Okay, so left double click zooms in and shift double click zooms out. Good to know, because I had been requesting, or well, I did make a request in the NNSVG repo for alternative zooming methods. But good to know that this is a thing. All right. What was I doing? Yeah, okay. So would this be considered a linear layer then? Because this takes in... Yeah, I didn't think about that. So maybe I was visualizing it wrong. Like this is a linear layer and this sends its output to another layer, which is, well, the output. So this input layer gets fed some data, right? This input layer has some data. I was kind of like, okay, where does the data come in this visualization? Because, okay, let's take a look at the linear layer. This is the linear layer. Okay, it has two. It shouldn't have two. It should have one. This was something I was doing yesterday, where I had set up the thing to take two inputs and give four outputs. Okay, so this is our linear layer. It takes one input and gives out 4 outputs. Okay. If this takes 1 input and gives out 4 outputs, what does this, what does, I think that returns a tensor, doesn't it? Calling L1 as a, no, it just returns a linear. No, that's a tensor. If I'm visualizing it, that's a tensor. Yeah, so this returns a tensor. Calling it as a function returns a tensor. Okay. That being said, what this returns is not 4 dimensional. What this returns is 4 values. It's a 1-dimensional array. It returns 4 values. Wait, that's interesting. It returns a 1-dimensional array with 4 values. Okay, okay. So when we call, uh, when we do the math, I'm not sure what I should call this. When we pass it through the linear layer, this is one, I guess this then counts as a linear layer, right? The input is not being visualized here. We are just assuming that we're going to pass one input here. If we were passing 2 values, then we would visualize it like this, right? So then this is our input layer. Our linear layer L1 is this, and our output is this. This is the output layer right now because this is just going to be using the output from the previous layer, right? So this could then be the 4 values. And if we introduced another thing, so okay, wait, let's kind of break this down. Okay, so we have a linear layer here that accepts 1 input. No, no. This, okay, right now this accepts 2 inputs. So let's take this down to 1. This linear layer accepts 1 input and gives out 4 outputs. Okay, and then we have another linear layer here which accepts 4 outputs and gives out 3 inputs. Now, if we are treating this as a linear layer as well, meaning we would have another layer here, then we would be saying that this linear layer accepts this accepts 4 outputs, but this gives out 3 inputs. No, what did I just say? This accepts 4 inputs, which are outputs from the previous layer. I kind of just like mixed up my words. This linear layer, this linear layer accepts 3 outputs. Did I just say outputs again? It accepts 3 inputs. Is it accepting 3 inputs? How does that work? No, I don't think that's the case. Wait, this linear layer is the number of neurons in this linear layer is how many output features it has, but that doesn't make sense because all 3 output features get combined into 1. I just fucked something up. I clicked on that one thing. Okay, wait, let's try that again. Let's try to like reset it somehow. Okay. Oh, wait, you can show bias as well. I just noticed that. Show bias units. How is it showing the bias though? Where have I specified the bias? Well, I mean, to be fair, I haven't specified the weights either, so I'm guessing it's just using random weights. But yeah, okay, back to trying to visualize this. Okay, right. So I'm having trouble figuring out what how I should be visualizing this. So let's get rid of this. Let's get rid of this as well, I guess. Oh, I should leave it blank to get rid of it. Okay. All right. So how are we visualizing this? Let's say the input layer doesn't count as a linear layer. Let's say the input layer is just the input. Okay, and then we have this one linear layer which takes how are we saying this? I think my confusion is coming from the way that I'm trying to um I don't even know what how to say it. From the way that I'm trying to theorize it, the way that I'm trying to say the description, the way that I'm trying to describe it, that's the word. I think the confusion is coming from the way that I'm trying to describe it. But okay, let's count this as one because I'm not sure if I should be counting this entire thing as a linear layer or it's just this thing as a linear layer. Why am I stammering, dude? Okay. Uh, so let's say this is so let's say this is a linear layer. Okay, and when we define this linear layer, we say this takes in one input and it gives out four outputs. Okay, I think my confusion is coming because I keep saying it takes in one input and it gives out four outputs. So like it takes in, as in the entire layer takes in one input and the entire layer gives out four outputs. Let's try a different way of describing this or a different way of thinking about this. Okay, let's say this is a linear layer that has one in feature and four out features, meaning for each out feature, there's going to be one expected input. I think that makes more sense. Yeah, because when we say that this linear layer has four out features, each feature is a neuron here, and each feature takes in one input. I think that's a good way to visualize it because then the if I changed the input to this, so then this counts as input. This is then a linear layer. This is our input. So if we then change our linear things definition here, So this has 2 in features and 4 out features, meaning this linear layer has 4 neurons and each neuron takes in 2 inputs. Okay, you know what? I'm satisfied with that with that with that line of thinking. Yeah, because that's making more sense than like I'm able to visualize that better than what I was visualizing before. Now what just happened? Okay, now this produces an output. We can read this output, but like it doesn't like give it out anywhere. So this input layer is our data. This is not this is a tensor. I was about to say this is not like a linear layer in any way, which technically is still true. It's not a linear layer. That's what I'm trying to say. So like this is a linear layer, but this is not. This is just a tensor. All right. What customization options do we have? Edge width proportional to edge weights. Let's try that. I kind of like that. I kind of like that. They're not visualizing it using numbers. They're visualizing it using the width of the edge. So a smaller value would be a thinner line, and a bigger value would be a thicker line. Yeah, I like that. I like that. All right, edge opacity proportional to edge weights. Oh, I could do that as well. Instead of this, we could just do opacity. I feel like that works better in terms of visualization, because when you do width and you start going too far away, it can become a little hard, as the pixels kind of have to like squeeze together. Though, I mean, to be honest, that doesn't look that bad. Yeah, it doesn't look that bad. Okay, I take that back. I don't think it's going to be that big of a problem. But yeah, I like this. So this is a way to visualize the weights. Edge color proportional to weights. Dude, okay, that's crazy. I like that. So blue is a negative color. Red is a positive color. All right, that's interesting. And then gray is the default edge color. So these are negatives. Wait, something seems different here. Okay. This was different because I was doing edge opacity proportional to weights. So that's why it wasn't allowing me to control the opacity, because the opacity was being set based on this. And then we have this as well for additional. Would I still need this though? I don't think I need the opacity then, because this mentions pretty well. So I guess the lighter the blue, dude, how would I go about visualizing these weights? Because like they could mention the weight on the edge, but I think that would make it look too cluttered. Now each of these neurons would have a weight matrix of the shape of the input features. So in this case, it would have a weight matrix of a one-dimensional two-element array. Oh, wait, no. Would it be a oh, okay. So this is another important thing to keep in mind is the shape of your input. As in, would it be a one-dimensional two-element array, or would it be a two-dimensional a two-dimensional array containing one-dimensional one-element arrays? Because the difference there would be in the former, we are talking about an array that has one row of data, one row of two elements, and in the latter, we are talking about two arrays, or we're talking about two rows having one column of data each. So I'm going to need to look into that as well once I get into higher dimension stuff. For now, for the sake of understanding the math, I'm sticking to the simpler stuff just so I can do the math on paper. Then I'll go into like higher. I'll increase the number of input features. I mean, at a certain point, doing the math on paper, which again, it's quote unquote on paper. Uh, at a certain point, doing the math on paper is going to become kind of hard. So I'm going to have to let that go. But I want to at least be able to do it with like lower dimensional stuff so that I understand what's going on. To be honest, I'm not sure how I'm gonna go about trying to understand. Wow, there's a lot of tabs here. I didn't realize just how many tabs I'd opened yesterday. Okay, let's close a bunch of these. Yeah, I don't know how I'm gonna go about understanding the math behind the convolutional layers and the recurrent layers. Though I mean the recurrent layers are more just like, at least from my understanding, the recurrent layers are more just doing that operation over and over again in the neuron. So I don't think that should be too complex to understand, but convolution, yeah, that becomes a little complex to understand. Because I need to understand what convolution is. So far, I just have like a very basic idea of how we get a patch of data and then use that as a calculation for another smaller patch of data. That's all I know in terms of like visualizing it, but like I don't know jack shit about convolution in general, so I feel like I need to look into it and understand the math behind it. At least get a higher level understanding of the math behind it. But okay, hold on a second. All right, you know what we're gonna do? We are okay. So I'm gonna raid. I'm actually hungry right now, so I don't know how long I'm gonna be sticking around in the person's stream. So I'm not sure if I want to raid, but like, wait, should I raid or do? Should I just end and then like do a raid some other day when I'm? Yeah, no, I'm starving. I'm because like I woke up a short while before. Now you know what? Okay, we're gonna raid Pixel Salad VT. They're a VTuber. They're working on something in Godot. We've raided this person before. They're pretty chill. But that being said, you know what? I'm gonna stream again later on. I'm gonna do a mute sculpting stream. So it's gonna be like an hour, maybe an hour and a half or something like that. So yeah, yeah. That being said, I hope you guys have a nice day, and I will see you all next time. Peace.